it's clearly something that has an understanding of physics that we don't, right? So this layered material. So I mean, here's an example. A friend of mine who has worked in the CIA and actually ran a number of programs in the CIA. He was in what was called technology acquisition. That was his thing. That's a nice way of saying he stole stuff from the Russians and the Chinese. He designed the programs that would steal things. He said that they would sometimes acquire technology from Russia that they actually didn't understand because the Russian physicists who had developed it started with different assumptions about things. Eventually, they were able to understand them, but it wasn't because the Russians got them from some other place. It's just because they had started creatively with a different set of assumptions about what something could do. And so, when you're talking about, let's say, an intelligence that is, let's again speculate, an intelligence that might be millions of years ahead of us, it has knowledge of how to manipulate the material world in ways that we don't. So the best we can hope is to emulate, and the best we can hope is to take it apart. Now, how would you do that? One of the instruments that we're building or trying to build in my lab is an atomic imaging scope, right? Something which actually sees the position of every atom. As it turns out, there's actually no instrument available today that does that. There are things called cryo-electron microscopy, which can maybe get close. Electron microscopy doesn't do it. There's crystallography, but crystallography requires things to be crystals, and so amorphous materials that have atoms more or less randomly placed, let's say, are not readable by this. So my position has been that if you want to understand some of these materials, you need the atomic position. An atomic atlas of what these things are, right? Now, at the same time as I'm developing that, let's say to do this, my primary interest in developing that thing is for my biology research, because it's one of those things that I said before is inevitable. Inevitably, we need to know the position of every atom in a cell if we really want to understand it, because form equals function, right? If you can understand the form of something, you can perhaps intuit the function. So, this instrument that we want to make has dual function. It can be used for this kind of materials analysis, any kind of forensic or actually research that might be going on in Silicon Valley. It could be used for metals analysis, or it could be used for the biology research that I want to do. So that, I think, is again an example of, you see something, you want to understand it, then you say, okay, well, what's the kind of data that I really need to understand what it is? I don't need to know necessarily what the elements or even the isotopes are. That's almost irrelevant. Knowing the position of those atoms in the material is what is important.